Hello everyone, welcome to chapter 4, sensitivity analysis and simplex method. In this chapter, we want to talk the effect of the changing each of the parameters of the linear program, and then we will introduce some basics of the simplex method. The sensitivity analysis is based on it's check the effect of the changing each of the parameters of the linear programs. For example, if we change the uh, uh, objective functions coefficients, what's going to happen to the optimal solution? We have already talked a little bit about the changing the parameters in chapter 2 and 3. But in this chapter, we will talk more about the sensitivity analysis, and we're gonna go more in depth. And then we'll later talk about the simplex method in this chapter. Simplex method is a very effective method to solve the linear programming, and it's a very fundamental, and you can we applied this model, this method, the simplex method in the solver, Excel solver, but we never talked about the details. So in this chapter, we are gonna talk about the simplex method also. So let's start the chapter. So in the all of the linear program we assumed that all of the parameters, all of the coefficient, including the coefficient of the objective function and the coefficient of the constraints, as well as the right hand sides, are given, and we know for sure. But in reality, that's not the case, because in the reality everything is changing in a moment. So we cannot have that kind of certainty about the parameters of the linear programming. The sensitivity analysis is the way that we can deal with this kind of the situation. Whenever we have basically sensitivity analysis answers to the questions that if we change any parameters of the model, it could be the change into one parameter of the model or several parameters at the same time. The sensitivity analysis helps us to have a understanding about the optimal solution whenever we do any change on the constraints or any parameters of the decision model. Recall the general formula of the linear programming that we had. The objective function is either maximization or minimization, and we have n parameters, x1 to xn. So these are the independent parameter that we are looking for, and then we have the coefficient of the objective function, which are defined by c1 through cn, and then we have set of the constraints that are defined based on the a11 x1 plus a12 x2 and so on. So this is the first constraint, and then kth constraint and the nth constraint that we have, and the type of the constraint can be equal, less than, or smaller than, or greater than, bigger than. So this is the three type of the constraint that we may have. So basically in this chapter we are looking for a clue that when we change any parameters such as c1, c2, or cn, or a1, a11 or a12 or b1, b2, what's gonna happen to the optimal solution. So in this chapter our focus is finding the effect of the changing each of these parameters on the optimal solution. Dealing with the change of the parameters, we can take two approaches. One of them is that whenever we change any data, any parameters of the model, we basically solve the model from the scratch, and so every time we do any changes, we solve the problem from the scratch. But the good thing is that a solver, the Excel add-in, provides the sensitivity reports that it helps us to understand the aspect of the problem better, because whenever we solve using the solver, it provides a different range that shows better understanding about the problem. You are going to see in a moment how solvers can provide more information about the sensitivity analysis. And the solvers, the sensitivity analysis of the solver, it answers to several questions, including the what's the range of the coefficient of objective functions coefficient that optimal solution is not going to change. So if any change of the C1 to 3 Cn, that still I'm going to have the same optimal solution comparing to the original problem. This solver answers to the question that if I change any right hand side of the constraint, that optimal function what's gonna be, and then also basically it answers to all of the parameters. Basically solver sensitivity report answer to all the changes that we may see in the in the linear programming model, including the objective function right hand side, and the impact of each parameter is going to show in the solver sensitivity report. One note that whenever you using a solver, make sure that you are using the linear programming model or simplex model in the solver. So that's the only program that provides the sensitivity information. Otherwise, we could not have that one. Let's back to the original problem that we talked in the chapter 2 and 3. And we had the objective function which was in type of the maximization. So we had x1 and x2 as the decision parameters, and the objective function was defined as a 350 times x1 plus 300 times x2, and we had three set of the constraint that it was about the number of the pumps and labor hours and tubing hours, and then we had the non-negativity constraints. So we solved this problem using the solver. So this is the example of the problem that we had. This is an objective function, and this is a constraint. So remember, we had three set of the constraint, and we want to solve this one, this problem. So the values right now is an optimal value. Let's change all of them to the 0. So start with a scratch and try to solve them. To solve this problem using the solver, you can go to data tab of the Excel and select the solver. And as you can see, because we already implement this problem in the solver, it remains in the solver. So we just click this one, and then we can solve it, and then make sure that the solving method is the simplex linear program. So we solve this problem. And when you solve the problem, you can see a pop-up window like this. You can select answers and sensitivity. To select both of them, you just click on that on each of this one, and then select the control and click on the second one. Whenever you press on the OK, you can see two new windows, two new worksheets are opened here. So, and you can see the objective value, and each of the optimal solution for each of the parameters are presented. So let's look at each of the answer reports. This is the answer reports. It has 4 sections. The top section is just summarize some of the basic stuff about the solver. So what type of the solver has been used, and how many minutes or how many seconds it has taken, and how many iteration is gonna use. So later we will talk about the iteration and this concept. But for time being, iteration is the number of the tries that the simplex method uses to find a solution. So it has just checked two solutions to find the optimal solution. And the report has a three section. You can see the first one is the objective section, the second one is the variable cells, and the third one is the constraint section. The objective function says we start out by 0 and we got this value as the optimal solution. So this is a value that we put for the objective function, and then we got this one as a optimal value. And then the second section of the report says variables, and it says what are the variables, which cells are defined as a variable, and what are the starting value for the decision variables, and what are the values we got, and then type of the decision variables that we are assuming integer and continuous. Then it talks about the constraints. So recall that we have 3 constraints plus non-negative of each of the decision variables x1 and x2, which are each represented in B5 and C5, and the first 3 constraints are the one that we defined. So you can see the left hand side of the constraint is 200, and the value of the each left hand side of the constraint is given. So, and you can see the objective value of the exact value of the decision parameters, decision values are given in these cells, which exactly match to these values, and they are positive. There is one column before the end, it says status, and you can see we have 2 kind of status, binding versus non-binding. Basically, binding means that this constraint is effective. It's the objective function that we got as optimal is the intersection of these 2 constraints. In another word, this constraint works as an equality constraint. So the first 2 constraints are working as an equality. We call them binding constraints or active constraint. But the rest of the constraint, you can see they are working as a non-binding. So that means these constraints are not active anymore. They are not working as an equality constraint. And the last column of this section shows a parameter called slack, and you can see the value of the slack is 0 for this one. Basically, slack means the difference between the right hand side minus left hand side. So the difference between E9 minus D9, remember that D9 holds the value of the left hand side of this constraint. So E9 minus D9 becomes 0. That means this constraint, the slack is 0, and this constraint is binding. So one way to see which constraint is binding, you can just check the slack. If the slack is 0, for sure that constraint is binding. Otherwise, whenever the slack is positive, then the constraint is not binding. Remember that always the value of the slack is positive. Is either 0 or positive, never can be negative. And you can see the third constraint, the slack is positive.